Again, welcome everyone. Thank you for attending our sessions today. So I'm going to jump right in because I know we got a pretty tight schedule. So I'm going to cover a couple of different key concepts in today's session. The first of which is using infrastructure as code to deploy an application into multiple production and development environments. And then how we're going to leverage that infrastructure as code to introduce monitoring and observability during the development process so that we can enable our developers to detect issues prior to pushing to production. And ultimately, our goal here is to build a bridge between development and operations. So I'm going to start off with just a few slides, but this session is going to be pretty demo heavy. And I'm going to try to go through stuff as relatively quickly as possible. And then we do have the face-to-face afterwards where we can get a little bit deeper and answer some questions you all might have. And so just a brief introduction to who Datadog is. Datadog is a monitoring and analytics platform. It provides full visibility across your organization and it spans end to end. So from your infrastructure and network to your applications and services, all the way to your end users. And so the idea here is to enable everyone. So if you're ops, devs, security, even folks within the business itself, so that you can have a shared understanding of your systems, your applications, and how your business looks from a technology perspective. But I'm going to use a hypothetical company to tell my story today, and that company is StoreDog. And so StoreDog has built out a cloud-native e-commerce application. And the StoreDog application is comprised of various components and services. So StoreDog has a Ruby on Rails front end that has some caching and a data store, a couple of microservices to do things like serving up ads or processing discounts, and then a shared database for those microservices. And so StoreDog is a new startup. So they originally started building these things out on one developer's laptop, pushing things out with Docker Compose. But now we're in production in Amazon Web Services, and they've chosen to use Elastic Container Service with EC2. And the StoreDog team, being a new young company, they're really ahead of the curve, and they actually are building all of this infrastructure out with infrastructure as code. In this case, they're going to be using Terraform. And this is all of the infrastructure. So starting from the VPC, setting up ECS, load balancers, Route 53, the whole stack. Now they're also even further ahead of the curve because they're deploying their applications to ECS with that same Terraform code. And so they've been able to bring up developer environments that mirror production inside of AWS. And they're really developing best practices, and they're seeing a lot of early success in the market. But then the tweets start coming in, right? So they've deployed out, the store is live, but they're clearly having some sort of growing pains. And unfortunately, the StoreDog team did not see this coming. So now the operations team is at a loss because they don't have monitoring. The development team is stuck trying to figure out multiple issues with little bits of information. And so StoreDog as a company can't really survive this type of bad press. And so they need this fixed quickly, but then they also need to make sure they don't get taken by surprise like this again in the future. So I'm going to jump over to a live demo. I'm going to spend a little bit of time going over the StoreDog deployment, how we're going to integrate Datadog into the multiple environments, and then using Datadog to create proactive monitors for the future. And so for the sake of time, the infrastructure and the environments have already been deployed. And so we also have Datadog enabled. So we're not wasting our time waiting for stuff to spin up. And I'm going to try to go through some of these bits a little bit quickly because, again, we're a little short on time. So I'm going to start in the AWS console. I think most folks here are obviously very familiar with the AWS console, but I'm going to give a brief introduction to ECS because it may not be something that you're necessarily familiar with. So ECS is a collection of clusters, and these clusters are the deployment and orchestration of containerized services. And so ECS has a couple different backends for compute, either EC2, where you're actually bringing up EC2 instances in different auto-scaling groups, or Fargate, which is an Amazon managed compute for these clusters. And so in the StoreDog cluster here for production, I've got a couple of EC2 instances that are going to provide compute for my tasks. Tasks, which are a definition of our different containers. So very similar to a Docker Compose. These are my image names, these are my resources, these are my ports, actually defining what that deployment looks like, and then a service, which actually orchestrates one or more tasks. So this will actually tell it how to deploy that set of tasks across your ECS cluster. And so I mentioned that they were building all of this out with Terraform. And so I'm going to go through our Terraform module that actually will show us how the StoreDog team is building out all their AWS infrastructure. This isn't designed to be exhaustive, but we're going to go through some of the main points. And so the Terraform module is in kind of 3 tiers. We've got the root of the module, which is where we're going to manage all of our account-wide things. So things like Iam Roles, which apply all the way to the entire AWS account, setting up the Datadog integration. Then we're going to move to the infrastructure tier, which is how we're building things like the VPC and our security groups, our ECS cluster, and then the application deployment itself. So now starting here at the bottom of our module at the root, we've got Iam roles. And so this is where we're going to use Terraform to set up the various Iam roles that we need for ECS. And so there's a couple different things that ECS needs to function. And then we also are going to have an Iam role for Datadog. So the Datadog platform can actually connect to your AWS instance, get all sorts of information about what's going on with all your different resources. So we do need an Iam role to open up that access to Datadog. And then I also have a Datadog integration itself, where we're telling Datadog how to communicate with AWS. We're going to get into how that looks from the Datadog console in here in just a minute. So at the next step, we do have the infrastructure. And so that's where we're actually going to start building things like the VPC. And so here's a Terraform resource for a VPC. You may already be familiar with that, but I do want to highlight something that we're doing here. So you're going to see this terraform.workspace. If you're not intimately familiar with Terraform, it works on a graph database with desired state, kind of similar to Puppet or Chef, where we actually will track the state of your desired configuration against what's actually happening in your infrastructure. And so we store that information as state. And so to make our code reusable, right, we kind of have that do not repeat yourself principle. We're actually going to allow us to have multiple versions of state against different environments. And so I'm leveraging Terraform workspaces for this use case, which actually allows us to keep multiple discrete instances of state. And so for our infrastructure, I have 2 different Terraform workspaces. I have one known as production and one known as development. And so the StoreDog team actually has a VPC that's dedicated to their production traffic, and then a VPC dedicated for development. And so throughout the rest of this, we're having things like our subnets, we're having our internet gateway, route tables, all of the things that you would expect at the VPC level. We're actually building out our EC2 instances for ECS. And so I'm going to highlight here that I've got a launch template inside of Terraform. So this is where we're actually defining what AMI to use, what our instance size is. And then I want to call out one special thing here, which is setting the user data. So ECS with EC2 works in kind of an interesting way. You define an ECS cluster, but the EC2 resources self-register against a cluster. And so they do that with some configuration on Box. We're passing that in as user data, which will get run when Cloud Init brings up a new EC2 instance. So that actually allows us to do auto scaling groups to dynamically size our compute for any given ECS cluster. So then here we'll also have like the auto scaling group I had mentioned that's going to use that launch template. I was even experimenting and using spot instances as well. So it really allows you to have a lot of flexibility when you start using infrastructure as code to build out these different types of environments. StoreDog also has an ALB that's going to front load everything. We're building one ALB per environment. So we have one setup for production and one setup for development. And I'll get into how we actually route traffic with that shortly. We've got the ECS cluster itself. And then we're going to get into the first service that we're going to deploy to our ECS cluster. And so here I've got an ECS task definition. As I briefly mentioned in the AWS console, a task is very similar to a Docker Compose. So this is actually how we're going to say these are the containers, in this case, an image that we want to deploy. Here are the physical restraints that we need in terms of resources. We're going to pass in things like environment variables, mount points, port mappings, all of those things that you would normally see in a Docker Compose are fairly well represented here in a task definition. And so scrolling to the bottom here, we then have the service definition for ECS. So again, this is the orchestration of that particular task, which in this case is the Datadog agent. And so we're using a scheduling strategy known as daemon. And so what this is going to tell ECS is for every EC2 instance in this ECS cluster, I want you to run a version of this task. And so we want to actually install and run the Datadog agent container on every single EC2 instance. And so what that gives us is a whole bunch of information from the EC2 instance itself. So we're looking at CPU, we're looking at disk, memory, network, all of those system level metrics that you get from there. We're also going to be connecting to the Docker daemon itself on that EC2 instance. So then we're able to get information about the containers that are running on it. And then we're also going to serve as an endpoint for our application tracing and our logs. So this is actually how we're going to collect all this information and then ship it over to Datadog from the actual boxes themselves. Okay, and then so the next level here, we've got the application. I'm going to only talk about part of this right now, and then we're going to come back to it when we get into monitors. So again, we have another ECS task definition. This is actually how we're going to deploy the StoreDog application itself. So again, kind of think about it like a Docker Compose. Here we're actually using some variables to pick a container name or a container tag. I'm just using some simple numeric values as I build up my demo. In the real world, you might be filling this in from your CI/CD system. It could be a semver, or you might be tagging on a commit SHA. It's again, the things you would see in a Docker Compose, things like environment variables. And I want to highlight some of these Docker labels that we're setting because they do have special meaning to Datadog. So all of the information that gets shipped to Datadog, be it metrics or traces or logs, include metadata, or what we call tags. And so we use those tags to correlate all of the information on our end. We use that to slice and dice the views. And there are three kind of special tags within Datadog. So the first of which is env, or environment. An environment is a collection of services. So the next thing here we have is service. In this case, we have the store front end. And so to map that together, you have the store front end running in the production environment. And then we have versioning for the services themselves. And so this might be version 1.0 versus 1.1. The reasoning here is that you can actually track the performance differences of a particular service between versions. So you might actually be deploying updated code and you're looking for regressions, you're looking for performance enhancements, whatever your desired outcome is. And so we've got the rest of our services that comprise the StoreDog app. So we've got the discount service. Again, we're tagging that within Datadog. You've got your ad service, we've got our database. All of this application is now described within that task. So in the real world, you might break that up into different tasks and different services. This is just a little bit easier for me to demo. So for the load balancer, we're actually going to create a target group for this application deployment. So for every version of this we deploy, we're going to create a new target group against that single ALB, either in production or development. And then we're also going to create a listener rule so that we can route traffic to that based on a DNS record that we're going to create later. And so that DNS record's down here. Some of these things are variables, so it's not super clear, but when Terraform runs, it actually gives us our FQDN for the DNS records. And so that's actually how we're going to deploy that service to ECS. You know, we had the task definition, we deploy it to the ECS service. We tell it how many count we want, what's our health check. So all of the different things that you would expect to manage that within ECS. And so now I'm going to jump over to Datadog so we can actually talk about how some of that information is getting into Datadog. I mentioned the agent, which is getting all of those kind of system level services, but the AWS integration within Datadog allows us to reach out to AWS and gather a lot of account-wide information. And so I'm actually going to skip the configuration of that for the sake of time. So I'm going to close a couple of these tabs, but I'm going to talk about the information that comes from that. So I mentioned that StoreDog is a new young company. They're experiencing some issues. They decided to sprinkle a little observability onto the problem. And so they're going to jump into Datadog. They're not necessarily familiar with it. And so we're going to look at some of the dashboards that come out of the box to help the operations team start figuring out what might be going on. And so here's just a quick dashboard that is the overall state of AWS for this particular account. I'm going to set this just for the last day. This is a shared account for me within Datadog, so there's lots of different information in here. But you can see things like how's your storage looking? How are your ELBs? How's your buckets? Things like RDS, EC2. So all of the different top level services within AWS. And then we also have dashboards for those individual services. So they're using ECS. Maybe we take a quick look to see what is going on account wide with ECS. And hopefully my internet is doing okay. Maybe I'll click another one here. Just looking good. Okay, cool. Yeah, that tab had a little cry. There we go. Okay, so then here's our ECS dashboard. We're actually looking at the different clusters. We're looking at our services and tasks. And then we've got a dashboard for the ALB. So again, this is account wide. We're going to use those Datadog tags to actually break out some of that information. So maybe I just want to look at my production environment here. So I actually only have a single target group host with a fairly low request per second right now, but a pretty high response time. And so from this basic set of information, I can see we have some pretty consistent traffic coming in, but we're also pretty consistently seeing errors, right? So there's some correlation there. It does kind of check out for what our users were reporting on Twitter. And so really this allows the new user to start taking different dashboards, getting the information that makes sense to them to start troubleshooting issues, and then building upon that. So I also mentioned that we have the hosts with an agent on them. So that actually comes back from our infrastructure list. So this is going to be all of the different hosts that are sending information into Datadog. So these are our EC2 instances. I'm just going to click on a quick inspect. And again, I mentioned this concept of tags. So we get some tags from the Datadog agent itself, which is going to give us some information about the physical hardware, CPU, disk, memory. And then we also are correlating and enriching this data from the AWS integration. So these are two different sources of data that we're now combining to give you a broader picture of this particular resource. So that's where you're getting things like what AZ is it in, what ECS cluster is it in, what Iam role has been attached to it, what security group is it in. And so we can actually use that to slice and dice the data as we go further. And so I'm a real visual person. I like to look at things in a host map view. And so by default here, we're actually separating our compute resources by availability zone. We're really ECS centric here. So I'm going to look at this by ECS cluster. And so this is now showing me my EC2 resources by a logical grouping, which is the ECS cluster, and then highlighting where they're at. Right now, we're looking at CPU utilization. It's relative to the currently displayed thing. So the darkest color is 7%. But then we can actually jump in and actually look at information about that host. So maybe I'm just going to jump to the dashboard, the network and the processes for that particular node. So then I can actually see how's the CPU looking, how's the disk, how's the memory, what's the network throughput looking like, where's the traffic going, what are the processes that are running on this box. And so the operations team has done all this, and they're still not figuring out what the root cause of their problems are, right? So the compute resources, the network, everything looks to be fine. And so they actually need to work now with the applications team to dig a little bit deeper into their problems. And so they're going to pair up and they're going to add application performance monitoring to their application. Depending on the language that they're going to go ahead and run, in this case, we've got Ruby and we do have Python. There's a few different ways that we need to integrate APM. So for Python, we actually just changed the way we invoke it. We pass the Flask app through a Datadog tracer. On the Ruby side, there's a little bit of code changes that needed to happen. But so the operations team has worked with the development. They've added APM. And so now we can actually start getting information about how their applications are functioning. And so I mentioned earlier on that we are using this concept of an environment. So up top here, we've got the production environment and then services. And so these are the services that are roughly translating now to container applications and what's their status, right? So here, very quickly, we can see that, yes, the front end does have a high error rate. It does have high latency. The discount and advertisements service also have fairly high latency. But again, we're looking at this right now as an operations standpoint. We don't necessarily understand how these services relate to one another. So we can also look at this as a map view. And you'll see this is where the screenshot came from in the slides earlier. This actually shows us how information is flowing through our different services. So if I look at the store front end, I can see what it's communicating with. I can look at the discount service and see how it's communicating. And this will actually allow us to start understanding what downstream services may be impacting our deployment. And so still with the operator's hat on, we're going to go ahead and say, you know what, we know we're in a degraded state. It did take us by surprise. So we want to make sure that if this is getting any worse, that we are proactively alerted to that. And so again, they're not necessarily experts in Datadog, but we can actually use some of the wizards to go ahead and create monitors very quickly. So we're going to look at the store front end. That's the thing that all of our customers see. We're going to look at some of the suggested monitors that we want to enable. And so I'm going to add high P90 latency. I'm going to look for high error rate, and I'm going to look for a high average latency. And so this now created monitors for the store front end in production for these 3 different types of metrics. And so I'm just going to go ahead and edit the high P90 one. And we actually show how a monitor is built. And then we're going to talk about deploying that with infrastructure as code. So at the top here, we actually have some historical data, the last 4 hours. We see this blue line. This blue line is this metric here. So we're actually doing an application trace, rack being the framework, which in this case is Ruby on Rails, and then the request duration for that particular service in production. And so we can see here that this is all very red. By default, Datadog feels like this should probably take no more than a second. And so looking here historically, we're bouncing anywhere between 4 or 5, sometimes all the way up to 15. So this is pretty choppy. We as the operations team have seen that we feel like maybe 7 seconds to warn and 8 seconds to alert is appropriate. And so we can kind of see here that we would be in the warning state from time to time. We would have alerted here during this spike. And this allows us just to kind of visually understand what this monitor would do. And then we've got an alert message, right? So just like any alerting system, what do we want to tell the receiver about this monitor? And then who do we want to send it to? In this case, it's just going to email me, the creator. And so I'm going to save this. And now we've created that monitor for the front end in the production environment. But again, we've got multiple services. We do have multiple environments. So we could just click through that wizard, n number of times for all of those services, run through here. But that doesn't necessarily give us a scalable platform for future services. It doesn't really help the development team as they bring up their own environments. And so we can actually export a monitor from within Datadog that gives you some JSON for our API. So you get things like the query that we're going to use. You get the message. You get your thresholds, all of the information that was used to build this particular monitor. And then you could copy this to a text editor, make some changes to it and dump it back into Datadog. But because the StoreDog team is so invested in Terraform, we're actually going to go ahead and put this into Terraform. And so I'm going to go back to my Terraform code here, and I'm going to actually start with the variables that feed into my Terraform code, because I feel like it's a little bit easier to understand this. So we've got a map of services. Here we've got a store front end, discounts, ads. We've got the framework, rack being Ruby, Flask being Python, and then some thresholds that we've agreed upon in the business. And so we can actually see that, on the store front end, these are lower than what we just set, but this is an SLA that we can agree upon. So moving forward, this is what we aspire to achieve. And so then we can feed that into Terraform with our different resources. So I have 3 Datadog monitor resources that reflect the ones I selected in the wizard: high error rate, high average latency, high P90. And so we're iterating through this list. I've got a Boolean on whether or not I even want to create monitors. So we take the service, which is the key out of the map. We're going to, again, use this Terraform workspace to determine what environment these things are running in. And then based on that environment, we're actually going to have different behaviors for our monitors. So if we are in production, right? So our local environment here is production. If this alert is triggered, we want to send it to Slack. So we've got a Slack channel here named alerts. But if we are in any environment other than production, we're not actually going to send this out. And so in the real world, you might actually say, if this is a development environment, send the alerts to the particular owner of that development environment, or send it to a dedicated Slack channel for development. And then also we've got this concept of re-notification or escalation. So again, if we are in production and this has not been resolved within 30 minutes, we now want to send out a page. And we're going to use PagerDuty for that. Again, if we're not in production, we're not going to escalate. And so we've also extracted out some of the parts of the query to use our variables so that we can actually use different frameworks with different services and different environments, and then all of our thresholds. So we're really using this infrastructure as code, do not repeat yourself principles. And so now all of this is defined in Terraform. The next time we deploy our production environment, we can include monitors with that. The next time we deploy our development environment, we can include monitors for that. So I'm going to go back to my services. I'm going to change over to my environment. Right now is Rick. And so we deployed this environment. It looks exactly like production, but now we're in dev, but I included the different monitors with it. And so I can actually go here and see that I do have these 3 different monitors that have alerted. So we've definitely hitting that in this particular environment. I can go back to the service map and I can see now that we are color coding our different services. So we're enriching this data. So the store front end definitely has a high error rate. It has high latency, but the downstream services do not seem to have high errors. And so that's going to actually help us start to dig into what might be going on for these particular applications. And so going back to the services, maybe I'm going to take a look at the store front end here. I can then start looking at traces that come in. So this is the information that's flowing into the front end. These are the different endpoints it's calling. Here are the metrics for that particular system. We're going to look at the index, which is the home page. I can look to see what this is calling out to, how long it's taking, how its durations are. And then I'm actually going to look at a trace of the application itself. So this is where the data is flowing in from the get all the way through the front end to our different backends. And that's viewed here as a flame graph. And so our request comes in here onto the store front end, and then we're actually able to follow that trace through our different services. So the store front end is actually calling out to the discount service using HTTP, which is one of our microservices, which is running in Python, and it's doing the same with our ad service. And so we've now changed the color here because we're actually following that trace through those additional services. So now we're in the Python applications, we can start seeing what's going on. And so looking at the discounts service, we can see that there's now a purple bar. That's actually the Postgres queries. So we're following it all the way down to the database level, and we can see all these different SQL queries that are happening. So this appears to be an N+1 issue. The developers can figure that out and work with the DBAs to get that sorted. But then we also have that our ad status is running slow. And so we can see that this is calling out to ads.status. So if we were to look at our Python code, we've got the ads service, ads.status. So the developer can look through here and see, oop, they actually left an extraneous sleep in here, right? So they deployed out some things that they were testing into production. And so because we're including these monitors with all of our subsequent deployments, as a new developer were to go in and deploy another version of this application, so maybe I'll jump over to Tyler. He has different alerts showing up here, right? But his error rate is now okay. So he looked at the errors in the front end, dug into that and fixed them. Then noticed that there was the N+1 error. He noticed that there was some of these sleeps, and then worked with Megan to fix that. So now she's deployed the fixes in her development environment, including those monitors, and everything is green. Now we still have maybe too high of latency. We as the business have agreed that right now that's within our thresholds, but that's actually going to give our development team the ability to start focusing their attention in future builds to optimize the overall platform. And so I believe I'm probably right around time. So I'm going to go ahead and wrap up some of my takeaways here, and then we can open up the conversation to questions.
Great, thank you. Yes, we're around time, so if you can wrap, and then I'll check for if any questions have come in.
Perfect. Cool. So yeah, so again, it was kind of a whirlwind. We talked about a lot of stuff, but the core of this concept here is that we are using infrastructure as code to deploy our infrastructure. We're using infrastructure as code to deploy our application. And now we're including monitoring and observability with those deployments. So that actually allows our operations team and our development team to have a shared source of information about the health of our application. It's also giving our development team insights into how the code that they're writing is performing. And it's the same information that we're going to get in production. So now they have a vested interest in what that monitor, what those SLAs look like. So we're all speaking kind of the same language. And so just a quick little wrap up too. If any of that kind of is information, if any of that's interesting to you, you want to kind of learn more about observability in a generic term, you want to actually look about how to implement it. We have learning labs on our website, which are free for everyone, which is learn.datadoghq.com. We also are hiring a bunch, so be sure to check out the careers page. And now I can breathe, and then I can answer some questions.